So for lack of log content, when I think of a log, it should have anything in it that can help us attribute to a user and understand the action taken. So that could include critical fields like a source IP address, a user agent, the actual event that's occurring, whether it was successful or failed. And it should be able to attribute the user successfully so that when incident response or detection engineering is looking at it, they know exactly what user account could be compromised through taking malicious actions. And then audit logs should have external-facing documentation. Some companies do internal-facing documentation, like CrowdStrike, where you have to log in to access it, but I'm a big proponent that it should be externally facing, so you can easily do threat research and understand what detection is actually possible based on the audit logs before you actually dive in. There's poor quality and inconsistent formatting. One of the examples I like to use is there's an unnamed password manager that previously had a Chrome extension, a software, desktop software, and a web UI, and all the logs were different depending on how the user accessed the system. And so if you think about it, someone exported passwords from the Chrome extension, but then that log looks different than if someone exported it from the desktop software. And so when you're doing incident response or detection engineering, you want to know if someone exfiltrated data. And so that audit log isn't consistently in that type. And so it's really important that across product versioning and operating systems, the logs you're seeing are the same, and you're able to deduce what behaviors are occurring and you have the same visibility. So you don't want to have a system where if they take an action out, like depending on the versioning of the update, you don't have any visibility into the critical actions. There should be a low rate of log quality related incidents. This is on the vendor side. So logs should be reliable and taken as a source of truth. There's occasions where maybe their system goes down and you have to backfill logs. But I'm talking more like when there's duplicate event IDs, there's issues with the formatting so that it's not being parsed correctly. Anything that kind of affects the log quality of your logs in your SIM. And there should be limited latency between an action occurs and the log event is available. So for example, if you think about, again, the Jira admin or like a GitHub clone or like any of these SaaS application actions occurring, by the time you're alerted of it, it's going through, it has to be generated, you have to pull it via the API, you have to stream it through any enrichment, and then it's going into your SIM, and then depending on how often your detections execute, and then you're getting the alert for the incident response team. So if the third party has a long latency between when the log is actually generated, then that's affecting your mean time to respond. It's affecting like how quickly you're able to, how long an attacker is in your environment. So this is really important that they prioritize limited latency. And then difficult log collection mechanisms. So you should have the ability to stream logs to a cloud storage or SIM provider. That seems really obvious. Not all SaaS applications do it. Some of them, they just allow you to view certain logs via the web UI. They only have admin logs, they don't have user logs. Like, there's a large variety, and these SaaS applications are not prioritizing the ability for us to get the logs, which should obviously change. Log collection should make it possible for event IDs to be sorted and straightforward. So you want to make sure that you understand the timeline of when events are occurring, and if an event occurs twice, that can mess up your incident response timeline, your understanding of the incident. So logs, again, should be the source of truth. And good log formatting and data structure choice is critical. Anyone that's been a security engineer on a detection response team can understand like the log ingestion part can sometimes take the majority of your job. The detection engineering part is the fun part. And so taking time to parse logs is not fun. When it's difficult data structures, it's even more difficult. So really making sure that the choice of the formatting makes it easy to parse and easy for detection engineers to get the information they need. And then the last thing I wanted to touch on was licensing and cost. If people have onboarded SaaS applications as a security engineer, sometimes you know that logs are not included. And I think that's like a big oversight in being able to have good security posture in that SaaS application. So they should be reasonably priced or part of the core product, and the process to add them should not be cumbersome. So if you want to know more, I highly recommend checking out the Audit Log Wall of Shame. It's at audit-logs.tax. It's a website that my ex-colleague and I maintain. But it goes over logging issues, pricing issues. For example, you can only export logs via the UI and batches of 500 messages per export, obviously an issue. Does not include audit events for project settings, group settings, deployment approval activity, time zone use differs based on where you view the audit logs. They don't consistently use UTC. All these issues make it really difficult for us to use the logs. So I highly recommend checking out that website. And also it's open source, so if people want to contribute to it based on their own experience with logs, please feel free.
What was it again?
Audit, it's
Audit log wall of shame.
yeah, sorry, it's super tiny. Audit-logs, not tax.
Okay.
Tax.
Yeah, it's based off of SSO Wall of Shame. So we copied the same format and same naming conventions. Also recommend checking that out. So we talk a lot about the restrictions SaaS applications put on us, but what can we do to make the data better? So these are kind of the two things that I go back to, having reference or lookup tables or caching data like in DynamoDB or something, and then data ingestion and cross-enrichment. So imagine we had a table in our SIM of all our EDR provider information, whether that's a source IP address, operating system used, user assigned, and then we have a table of lower risk device activity, higher risk device activity. We can reference that in our detections, kind of creating a risk-based detection without having to go through the whole process of contributing the scoring for all of our assets and entities. And then for data cross-enrichment, imagine that same IP address is enriched into every other log source for that user to understand if they're accessing that application from a known location. So a good example for this is, again, if you have EDR logs or even IDP logs, you can understand more context about that user, and you want to bubble up that context in every single log you have. The downside of this makes your logs bigger, so pricing concerns, but it gives both the detection engineer and the incident response analyst the context on the user as they're looking at the raw log. So they're able to say, this user has these permissions, they're an HR analyst, they're coming from an IP address that matches the IP address in the last 24 hours from our EDR. So we can say it's a corporate device. We can understand other aspects of this, and this really helps us with detection engineering. So let's go into some attacks and detections we can write. First, my perspective on approaching the detections for SaaS. I like to do threat research on the active attacks that are occurring for these environments. And then I love diving into API activity. You get some really interesting stuff, especially if they have API activity and not token usage logs. So you can see how tokens are used. Yes?
What threat research tools are you using?
Google.
Are you using the Mandiant Intel, or are you using?
So depending on the SaaS application, there's reports that have been created by like Mandiant or other organizations, and then there's also just a lot of logs. There's a lot of people that have like exploited things, that have seen things in the wild, that companies that have been hacked that have wrote briefs on it. So kind of anything that relates to a SaaS application threat. So usually it's like whatever the SaaS application is, active threats, and then going through a bunch of pages and like reading links and the links that connect to the links and all that.
Yeah. Recorded future or anything?
Oh, we don't use that. And like I've never had a company that wanted to pay for it.
Okay.
Again, like API activity fund, user and service account behavior analysis. It's really interesting to see how users are using your environment, if service accounts have been compromised, what their behavior usually is. If you think about a service account, they usually take the same actions consistently. So deviations from that are definitely interesting to look at. The token usage, which I'll dive into with detections. And then you know your environment best. So what are your critical SaaS applications? What are the assets in that environment? What data does it have access to? It's really like a practice of threat modeling your own environments and prioritizing SaaS applications that have your critical data. And then from a minor attack perspective, these are kind of the four I focus on when I'm first doing an MVP for detection writing. So the initial access or credential access, you can look at the token usage, you can look at the login activity, you kind of get your basics down. Then looking at persistence, and then collection and exfiltration. So usually when an attacker is in a SaaS application, their goal is to exfiltrate as much data as possible, potentially impact your environment. So you'll be able to see, because the idea is that they can extort you, you'll be able to focus on exfiltration behaviors that they can take. So some of the inputs to detection engineering research, that audit log documentation I mentioned that should be externally facing, taking a moment to look through all of the event types that are possible. A past history of log data to use for hunting, usually I do 6 to 8 weeks. Research using those current security articles and content, and then threat intelligence indicators. So whether you have a service you pay for or you have an internal team that works on this, being able to incorporate any of that stuff is really critical to your environment, especially if you know that there's an active attacker targeting organizations that are similar to yours. So I'm going to focus on 2 cases for attacks in detection engineering. I'm going to look at GitHub and Snowflake. So both of these applications are pretty critical to organizations. GitHub, you have intellectual property, you have your deployment, you have a lot of secrets potentially in there, tokens that you can use to access things. And then you have Snowflake, which has financial data, personal data, customer data, and has becoming a really large platform that a lot of companies use for data warehousing. So I think this is only going to grow. So let's talk about GitHub log visibility, my favorite topic, back to logs. GitHub actually has pretty good logs now. It hasn't always been that case. They have GA attribution of user email addresses to activities in the audit logs. So what that means is before, if you were looking at a GitHub audit log, you would see someone's GitHub username. And if you looked at people's GitHub usernames, they're often not their name. And then it's really hard to attribute that activity back to a user in your organization. And so they added user email addresses, so you can see the user email address, usually it's the corporate email address that's committing something, that's taking the action. Really, really helpful for understanding if there's behavior outside of your organization taking activities within your environment. Like if someone accidentally got their personal email or like an attacker added an email to your organization, you can look at that. They allow the ability to include source IP address in logs, so this isn't by default, you have to toggle it on, which is like a slight downside. But that's critical for user attribution and understanding where behaviors are coming from. They then provide granular detail on the type of token taking the action. So there's 4 token types, and it provides you in the logs the token type. Sometimes when it was generated, just the OAuth access token gives you a time frame, and then the hash token, and then the behaviors that are occurring with that token. And then there's now GitHub API request logs. So you can see granular usage of those tokens to take actions via the API, which is super valuable. So let's talk about some GitHub threat actors. I kind of think about it in 2 different buckets for GitHub. You have various groups that do malicious payload delivering packages. So deliver these malicious payloads, trick users into executing packages, downloading repositories, and then eventually possibly data exfiltration. And then the other group, or there's various groups that do it. One of the most notable ones is Shiny Hunters. They do credential theft and data exfiltration, so they're actually focused on compromising those user accounts through credential theft and then exfiltrating data, stealing access keys, and then ultimately extorting companies. So for GitHub detection focus, there's 4 that stuck out to me when I was initially looking at it. Abnormal usage of access tokens, right? There's previous proof that threat actors are extorting these. Utilizing stolen credentials, credential theft, repository cloning behavior, so that exfiltration of intellectual property, and persistence through new user accounts. So we're going to talk about abnormal usage of access tokens. In April 2022, GitHub Security announced that it detected the compromise of OAuth access tokens issued at Heroku and Travis CI integrations, and that was used to download data from a lot of organizations. So there's definitely activity in the wild that they have admitted that is using the compromise of OAuth access tokens to exfiltrate data. Then in October 2023, in another compromise, organizations found that attackers accessed GitHub accounts using compromised personal access tokens, most likely from malware that was on someone's endpoint and grabbed it from the development environment. So looking at example detection, we're looking at GitHub OAuth token actions taken by various ASNs and user agents. So the idea here is that we're looking at differing locations and differing devices based on the data that we have. So the 2 is kind of like, I just put it in there, we can do more depending on your environment, but you don't want to see people taking GitHub actions using an OAuth access token from multiple locations and different devices in a short time period. This is also based off of an approach to detecting Okta session hijacking. The only difference between the GitHub logs and the Okta logs is the Okta logs provides the session ID, so you have a little bit more fidelity in that. But you can definitely dive into abnormal actions by OAuth access tokens. You can do anomaly detections, basically focusing on when this is deviating from when it's typically being used. Then we're looking at personal access tokens. I couldn't include the whole detection in the screenshot, but the idea is that you're looking at get clone events and when a personal access token is created. And you want to look at maybe, depending on your environment, the personal access token is created, and then 5 repositories have been cloned, 10 repositories have been cloned. And then if you look at the ability to add reference tables or lookup tables, you can actually get a list of new hires in your organization are classified by Okta data and your IDP, like wherever there's like user roles. You can see a new hire tag. You can actually exclude them. Because if you think about it, like a new hire is going to clone 10 repositories, right? And you don't want IR team to get a detection fired every time that happens. But it is really interesting because if you're going to exfiltrate data via PAT, then you're going to try to get as many repositories as you can before you're detected. And then another one I want to look at was API request logs. So GET requests to secret pass minus the public key. Understanding if they're accessing secrets in your environment. And if that's a compromised token, you also get the token usage information. So there's some additional detection ideas kind of that I've been thinking of and also have like written in the past, such as an SSH key created from a suspicious IP address. I say suspicious IP address because a lot of people do use enrichment, so they understand what's like if a detection is or a log is coming from a residential ISP, corporate VPN, if it's coming from a Tor, if it's coming from a hosting provider. So you can actually, if you have this enrichment, focus on, what is the behavior that we're expecting, usually residential ISPs and corporate VPNs, and you can tune that. A private repository changed to public, super significant. User downloaded data as a zip file, so GitHub allows you to just download a repository as a zip file. So that's another way that you can use your access to exfiltrate data. GitHub also has kind of an unknown user field. I haven't seen it used a lot, but it is available, and it gives the ability for a non-opt user when email join you. Next, we're going to talk about Snowflake. Snowflake threat actors. There's one major one, kind of the only one we know about. It's pretty new. Who has stolen significant number of records from Snowflake customer environments. And they use InfoStealer malware to gain user account access. They log in, they exfiltrate data. And in some cases, they use client applications to get access and exfiltrate data. There's kind of a couple methods, but usually it's just a user account, no MFA, login, suspicious IP address, grab data. And we're going to talk about once they log into Snowflake, what are the behaviors they actually take. So once they've logged in via stolen credentials, they show and select tables within your environment. So those critical tables where you're storing data, potentially financial data. And then they're going to create a temporary stage. So for the folks that aren't familiar with stages, they're a way to load and unload data in Snowflake. So they're going to create a temporary stage in order to store that data that they're grabbing from those tables. So they use the copy into command to copy into the stage, so moving that data where they can access it. And then they get the data through stage to their local machine or an external cloud provider. So looking at some attack techniques, focusing on client applications, which I mentioned before, was that way that you can set up automation or third-party integrations with Snowflake, exfiltration behaviors, data transfer actions, and malicious IP addresses. So I'm not going to touch on malicious IP addresses or data transfer actions, but I highly recommend looking at the Snowflake audit log documentation, and then the Mandiant or Snowflake report on UNC 5537. They have IP addresses that you can use as indicators of compromise. Of course, those are always changing, but it's nice to have a detection with it when you know the threat intelligence. And then also data transfer actions. There's a couple different ways to do it. You can look at the audit documentation. They have pretty good logs. We're going to focus on exfiltration behaviors. So again, Snowflake announced the compromise of 200 plus customers that had data exfiltration and then extortion by UNC 5537. And then there's kind of not any other threat actors right now that have been talked about. And so we kind of are in the position where we don't know when the next one's going to be, but as Snowflake grows as an application and storing more and more critical data, it's only a matter of time. And so we're going to look at that Snowflake stage behavior. So we're looking if it's set to an anomalous external cloud location. Right now I have the stage being created and then the stage URL, which is the export location. If it's an S3 bucket, GCS, or Azure, so that covers the 3 major cloud environments. We want to get a detection written, and those are the ones that are supported by Snowflake. We want to get a detection if one of these stages is created. It's pretty infrequent in a lot of environments. And then we want to understand where that data is being exported to. Another one is looking at users anonymously querying data. So there's this table called query history. It captures every query taken in Snowflake and every command that is listed in that query. So we're looking at when a user deviates from their typical behavior interacting with a single database. So we're looking at that name and then the user that's taking that action and if there's anomalous amounts of querying. So if a user account has been compromised and then they're able to take it and use it to query a bunch of tables at once and then exfiltrate that data. And the last one I want to talk about directly to the UNC 5537 attack. They use this copy into command to get it into an external location. So they provide a path, and then they would copy the data into it directly. So this is a good one to maintain, and this is actually, instead of a detection in the SIEM, this is actually a detection you can deploy directly in your Snowflake instance. So it's a query, you can do a monitor in Snowflake, and then get an alert or an email or a Slack notification if a detection like this fires. Yes?
Do you find more effective detections using built into the SaaS application alerts like this, as opposed to your SIEM? What's your go-to?
Depends on how the SIEM is parsing the logs. So if the SIEM is parsing the query history and you're able to easily search it, I'm a big fan of keeping all detections in one place. However, there are instances where you keep detection as code in a repository, but they get deployed to different vendors. So maybe you deployed some stuff to like CrowdStrike for like an EDR alert, and then some to your SIEM for like SaaS applications or other logs that are streaming in. I think when there's an incident that's occurring where you need to quickly deploy detections, it can be quicker to do it in the SaaS application itself if it supports it. If not, I would say like keeping everything centralized is really nice. In response to the Snowflake attack, this is a detection that like I wrote to be deployed directly in Snowflake, and we wrote all of our detections in Snowflake first because it was faster, and then we made sure the data was cleaned and normalized into the SIEM, and then rewrote them into the SIEM. Some additional detection ideas for Snowflake is looking at those new client applications. So UNC 5537 used 2 client applications that were malicious. One of them is called dbeaver. It's actually like an open source tool. It's used legitimately as well. And then a homegrown client application called RateFlake. And so understanding when these automations and drivers are set up in your environment. Grants of admin role to user and network policies modified. As I mentioned earlier, you want to understand what IP addresses are accessing your environment and what behavior you're expecting. And only admins are allowed to modify network policies. So if you want to read more about threat hunting in Snowflake, I wrote this article when the attacks first came out, like information about them. And it actually is Snowflake specific in that you can go through and it'll all be queries in Snowflake query language that you can deploy to your Snowflake instance and do threat hunting or proactive detection writing using their alert system. And it walks through what each of the queries mean and why it's important to your environment. And then that's it. I wanted to thank everyone for listening to me spiel about logs and detection. If you have questions, go ahead and ask them. You can always reach me on LinkedIn or afterwards. I will open source my detections on GitHub and then also provide them through the link that they're collecting for BSides. There's a lot of good links on things like attacks, sources that you can use for log collection, information on, again, audit logs.tax, detection writing in general. And then there's some out-of-the-box detections that I linked here. that are good to check out. And then there's a GitHub detection specific BSides talk that was at Las Vegas this year by a friend of mine. Highly recommended. He talks about setting up a detection as code pipeline and then detecting GitHub threats. So it's really good. Thank you. Does anyone have any questions?
Hi. Earlier in your talk, you rattled off a bunch of things that SaaS applications should be collecting in their logs just as kind of a baseline. What were those?
So I would say username or user email, source IP address, user agent. Optionally, like geolocation information. You can enrich that yourself, but it's really, really nice when a company does that by default. And then the action they're taking in a very clear way of whether it was successful or failed. Yeah, of course. Yeah.
I was going to ask basically the same question, but I'm not good enough at taking mental notes. What reference can I go to find what's similar to that? To teach software engineers how to write reports.
So, if you go to auditlogs.tax, it has information on some of the, like basically the exact presentation I went through in the beginning about logging restrictions and quality. All of that's published there. And then I also have a Medium blog that's about how to create audit logs for security professionals for the persona of a software engineer.
Perfect. Thank you.
Yeah.
So in detection engineering, which do you think is more useful, like understanding straight code or like query language? Because like each sim has their own flavor of query language.
I think like, yeah, understanding how to do data querying and having the ability to learn new systems is really important. I think coding can also be important depending on like what position you're doing and if you're like doing automation or scripting, doing log parsing, it kind of depends. But querying languages is really, really powerful. I think that there's a misconception in security sometimes that like if you don't have experience with a tool, that like you're not be able to like adopt to a new tool. And I think that's like really harmful for like people that use SIMs because it is really similar. There's good documentation. As long as you have have had experience with data before, you can do it.
Yeah, for sure. So I guess follow-up question, do you think that realistically there may be some standardization in the future of query language, or they're just too siloed?
I think there's too many vendors doing too many different things.
That's what I figured.
Yeah. I wish.
Yeah, I mean, that's what I was like, but you know.
Yeah, and I think that there's adoption of like maybe not the information going into the audit logs, but for formatting purposes, like using a unified data model like OCSF, Elastic, like ECS, super helpful for detection engineers. But I don't think we're going to get to the point where the logs itself always look the same or the query language is always the same.
Unfortunately, yeah.
Yep.
You all integrate any sort of like UEBA product or service, and if you do not, how do you get that like established baseline of what it's like?
Yeah, I think this goes back to a little bit of like the risk-based detection writing. So like you want to understand the risk of user behaviors and what is typical for that environment. I'd say the biggest challenge is having good data. And a lot of times, if you have data piped into your SIM that's enriched and formatted, then you're at the point where you can start considering that. But if you still have poorly formatted logs, you're not enriching data, like you don't have information on the users and the entities in your logs, then it's going to be really hard. But I think bigger detection engineering teams where you have like 10 or 12 detection engineers, they're like a lot more focused on that when you look at detection and response teams with 3 people.
Since you're here, you'll get to hear this multiple times. Speak louder than normal. Okay. Repeat the question.
Okay.
Because until I find a microphone and have somebody run around, not everybody can hear you. Okay.
Yeah, I'm going